Okay, this is a solution for quiz number 20. Okay, so in this case, we know that the when we do the current and voltage across an inductor, we know that the current is going to be given by this equation. In other words, I of t is going to be I final plus I, I initial minus I final e to the minus t over tau. And then the voltage here is going to be given by L di dt. So once we find I through the inductor, then we just differentiate to get the voltage. All right, so what we need to do is we need to find, IF, I naught, and tau. All right, so to find I initial before the switch is closed, so this thing is open. So basically, this part of the circuit is not there. And so, and after everything has died out, we basically have the current flow. This is basically a wire, so all the current is going to go in this direction. None of it will go through the resistance because basically, or the resistor, because you have zero resistance here. So I initial is going to be minus 4 amps. Because the 4 amps is defined in the opposite direction as I. All right, so I final, with I final, we this thing is going to be closed, and so again we let everything die out, and this will be a wire. When it's closed, then these two combine and you get 16 amps. And even though these resistors are combined in parallel, all of the wire will, or all of the current as time goes to infinity will just flow through here. So I final is going to be 16 amps. Okay, now tau is computed by sort of looking at this box, looking in and finding the Thevenin equivalent after the switch has been thrown. So we can do that by, basically combining the current sources. So when we combine the current sources, we'll have 16 amps. And then combining the two resistors in parallel. So this will be 8 in parallel with 2, which is 16 divided by 10, so 1.6 ohms. And then, this is the Thevenin. We're trying to look into this current. So the Thevenin resistance here is 1.6. So tau then is going to be L over R Thevenin, which is going to be 32 microhenry divided by 1.6 ohms, which is going to be equal to, let me pull up my calculator here, 32 e to the minus 6 divided by 1.6, and I get, 0 point, is that right? 10 to the minus 5. I get 19, basically 20 microamps, or microseconds. Let's see, 20 microseconds. Okay, so the current then is going to be I final, which is 16, and then we're going to have plus 16, and then you have a minus 4 minus 16. So this is going to be minus 20 e to the minus t divided by 20 microseconds. All right, and this is going to be in terms of amps. All right, then to find the voltage, we just simply divide. So the voltage is going to be L or differentiate L di dt. So L is the 32 microhenry. And then when we differentiate the current, so differentiating that guy gives 0. And then when we differentiate, so we'll have minus 20 times the derivative of this thing, and it'll be, so the minus 20 micro will come down here, and then we'll get this guy back. So we'll have so we have minus 20, and then that's going to be times minus 1 over 20 microseconds. And that'll be e to the minus t over 20 microseconds. And so in this case, the 10 to the minus 6s cancel out, and we get, and then the positives cancel out, so we'll get a plus, and then the 20s cancel out, and so we'll get a plus 32 e to the minus t over 20 microseconds. So the voltage is going to be 32 e to the minus t over 20 microvolts. Okay, there's the solution.